Hello, my name's Bob Ferris. I'm an executive advocate with Murphy Business and also one of the co-creators of the new book, Business Model U. Business Model U was a very exciting project to be a part of. The thought was, could we take the business canvas method, which was very successful in reinventing businesses, and use them to reinvent an individual's own career? After all, your career is a little mini business. Why shouldn't it work? And the book is very successful in delivering something called the personal business model for anyone who works through it. The challenge is, once you've developed that pathway to how you would like to reinvent your career, can you actually implement it? And working with people doing this, it's become very apparent to me that requires a particular key activity that's going to drive the change in your life, which I've called SOP, for Standard Operating Procedure number 1. Now, there are some interesting dynamics when you try to do something to implement change and you're doing it over and over again. I had an earlier simulation that illustrates that pretty well. You can find it on the internet. If you do a Google search using my last name, has kind of a unique spelling. It's F-A-R-I-S-S, Ferris, and then we do paper folding. And ask Google to look that up, and we'll find Bob Ferris's simulations, and you will come over to this Foreo simulation page. It asks the question, if you could fold a piece of paper in half 42 times, how thick would it become? Now, the reason this simulation was originally placed here on the internet was to show how difficult it is for us to intuitively think about things that are not linear. Folding a piece of paper in half is exponential. So if you were to mentally just decide how thick is this paper after 42 folds, you're going to see something interesting by running the simulation. Simulation consists of a graph. This is how thick the paper is going to be in meters, and this is the number of folds that we have over here on the horizontal axis. There'll be the actual measurement in meters here, the number of folds currently in the simulation. And the way we fold paper on the computers, we just click this big button here, all right? You click it once, and we have a piece of paper that's been folded one time. Now, a picture over here appears that changes periodically to give you a feel for how thick the paper has become. And right now, it's just as thick as a piece of paper that's been folded over once. It's so thin, in fact, it really doesn't show up on our scale yet because we're scaling in meters. So let's run it about a half a dozen times and see what happens. And after half a dozen folds, really nothing much has changed. Now, in life, that's very challenging. Okay, you're doing something and you're trying to implement a change and you're doing it over and over again and you can't see the results. Okay, now if we fold it a 7th time, it's actually become as thick as the thickness of a dime. All right, you see the pictures start to change here on the 7th fold. I'm going to run this out. Now it's about as thick as a cell phone, a little over a dozen folds. And what you'll see is at a dozen folds, the paper has become at least a meter thick. And you're going to notice the shape of the thickness curve. All right, you're going to have something that we call a hockey stick curve. And the hockey stick curve has two interesting characteristics. The first is very rapid growth here on the handle side of the curve. But also on the blade side, the appearance of nothing happening for a while. There are many processes that are very dynamic and very fruitful, but they have a gestation period. Okay, it looks like nothing's going on for a while. And people sometimes take a look at this and they'll go, oh, geez, nothing was going on. And then right here, about a half a dozen folds through, it looks like you changed something. And now whatever it is you were doing is working. I'm the one that programmed this model. I'm the one that clicked the simulation. And I can tell you that at that point in time, absolutely nothing changed. But the world is full of success literature where people have looked at that and they said, oh, geez, you're right. I wonder what happened at that point in time. I think that's when I started eating cereal for breakfast, and that stabilized my metabolic rate. And they came up with, I don't know, a new book on managing your caloric intake for business success or whatever. And these are very well-meaning people with data that can support what they're saying. But when we actually build the systems and we attempt to simulate them, that's not what happened. Two things did happen. Back here in the beginning, we decided to start standard operating procedure 1, which was we're going to fold a piece of paper. And then the second thing that happened is, even though we were in a gestation period and even though we didn't see results, we still believed in the process. We believed in what we were doing, and we kept folding anyway. Those two things are the keys to making the implementation of a personal business model work. You need to find that core reinvention process, and you need to keep believing in it. Now, we speak about pivoting your model, and that's important. All right. In the beginning, you need to be able to test and validate what you have actually works. But once you do, there's a process that's going to take some time and some belief. Now, there's more to this model. I do encourage you to try to figure out how thick will this paper be after 42 folds. I've taken you about a quarter of the way through it. You see the hockey stick curve. Maybe it'll give you some more insight. And I challenge you to come back here and try it for yourself and realize the power behind a dynamic SOP1. There's a whole lot more on this topic. I encourage you to read the book, look up Business Model U on the internet to find out more about the methodology. You can also do a search on Executive Advocate to find out more about our program. Take care.